Hello, and welcome to my session. My name is David Dye. I am a teacher at Barton Academy for Advanced World Studies in Mobile, Alabama. Thank you for attending. We're just going to go ahead and get right started. So this presentation is about project-based learning in mathematics, building engaged learners in a thinking classroom. I do want to provide a little bit more context as to who I am. Again, my name is David Dye. I am a Vietnamese American teacher, beginning my 7th year of education, and my 3rd year teaching at Barton Academy for Advanced World Studies in Mobile, Alabama. I was the 2020-2021 Alabama Secondary Teacher of the Year and State Alternate. I am currently a National Board Certified Teacher, a 2023 State Finalist for the Presidential Award for Excellence in Math and Science Teaching, and a current board member for the National Council of Teachers of Mathematics. So a lot of my background that I'm sharing here informs much of the work that we're going to be hearing about today. So my agenda, this presentation falls in the theme of leveraging STEAM applications for in-demand careers. So that's where I'm going to begin by thinking about what are employers looking for in their employees. And from there, transitioning to how does project-based learning support students in attaining these skills that employers are looking for? What is it that teachers need to do to support students in a PBL learning environment? How does a thinking classroom then support PBL for both teachers and students? And then I'm going to close with some recommendations for how you might get started on your journey with PBL. So when I ran a quick Google search for, what is it that employers are looking for, I came across a LinkedIn article that shared these top 5 skills/traits that they're looking for in their employees. And they include effective communication, leadership ability, problem-solving prowess, a strong work ethic, and the ability to collaborate/work in a team. So if these are the skills and processes that employers are looking for in their employees, how might we as math classroom teachers develop the capacity within our students to engage and do these things? And for us at Barton Academy, that answer is project-based learning. So how does project-based learning, and PBL, as I'm going to refer to it as well, support students in attaining these skills? And where I want to begin is by thinking about what PBL Works has defined as 7 essential project design elements. Now, when we think about a PBL project, we're beginning with a challenging problem or question. So this is what you as a teacher are posing to students, the question that you're asking, the problem that you're posing for students to investigate, inquire, and then conduct their research and engage in the project work is what begins any project launch. You want to ask a question or pose a problem in such a way that it sustains student inquiry. The work that the kids are doing needs to continue to be engaged in such a way for students to continuously ask questions. As they're going through this process, they're looking for resources, they're taking that information and then applying it back into their project. So you're posing a question to begin. The kids then investigate that question, they ask more questions, and then they're continuing to do this research. And all of this leads into the authenticity element of a project where if the question that you're posing, the challenge that you're providing to students is something rooted in a real world context or is related to personal concerns that they might have, personal interests of theirs, issues that are relevant to students' lives, then the work that they're doing, the work that they're engaging in for their project is that much more authentic, relevant, and real. So we want to provide opportunities for our students to continue to ask questions that are meaningful to them as they're engaging in their project, and that's part of that authenticity element. And that lends itself to, as well, not just the question part, but the tool aspect of things. What resources are they using? What technology pieces? What physical manipulatives might they use? So we want to create authentic learning experiences for our students as they're engaging in the PBL. From there, as teachers, we have on our end the opportunities to make decisions for our students on a daily basis. But in a PBL setting, we offer students voice and choice. So we have to come up with a plan and decide, these are the elements that I'm going to let my students choose throughout their project. And it could be the choices that they're making are how is it that they're going to work within their groups. The choice could be what final product am I going to create to demonstrate my learning of this concept or procedure as I'm engaging in the project. And obviously the voice side of things is for students to express their own ideas, their own voices in an active way. A critical part to a PBL project is the reflection piece for both the student and the teacher. On the teacher side, we're reflecting on instructional practices, lessons that we're employing to make sure that students are still attaining the content that they need in order to be successful in their engagement with the project and the production of the project. But for the student side of things, we need to be thinking about how we can support our students in reflecting on the quality of their work. And not only the quality of the work, but the depth of their understanding as they're engaging in the project. So however it is that we provide those reflection elements, I think traditionally we're used to providing exit slips to students for them to reflect on the day's learning. We could provide students opportunities to journal, but all of that's going to look very different. And for us as the classroom teacher is going to be rooted in our knowledge of students. In addition to that reflection piece, there is the critique and revision aspect of it all. We continue to provide our students feedback on where they're at with their project, with their learning, and they continue to make progress with that learning. They revise and make edits to whatever their project is, or they go back and rework problems in order to understand the content at a deeper level. And this critiquing doesn't necessarily have to always come from the teacher. Students can give and receive feedback from their peers as well. And so we want to create a culture where students are communicating with each other, not just us when they're looking for feedback and then applying feedback to improve the processes that they're engaged in, as well as the products that they're producing. And then finally, the last element of a project is the final public product, right? The thing here is the product that students create should not be only for those in the classroom. The idea of a public product is that we're making this visible for those outside of the classroom, ideally to families and communities that are invested in the students at that school. So what you see here are a few examples of PBL projects that I've engaged in and have supported students in completing over the last few years. Just to give you an idea of the content that we're addressing and how students are producing them. In the center here, you can see a Desmos graph where we were in a linear functions unit, and I tasked students with using linear functions to write I am sentences. Our school-wide project-based learning theme was very much about self-discovery and figuring out who we are. And so I tasked students with telling me who they are using linear functions to create vertical and horizontal lines, as well as lines where the slope was not zero or undefined in 3 different forms of a linear function: slope, intercept, standard, and point slope. And so for me, it was a way for students to demonstrate in a very applicable way for them to express who they are and showing me the depth of their understanding. So on the left-hand side of that image, you can see all of the, or some of the equations that the student Lola used to write these, and then you can kind of see the adjective that she used there. On the far right-hand side, in a probability unit I challenged students to think about, and again, we were doing a cross-curricular PBL with other content areas. So we were looking at the dangers of unsafe water, thinking about water safety, how pollution affects water. And so Lauren chose to create this infographic where he's color-coded across different regions of the world, you know, how the population has access to or does not have access to clean or unsafe water, and then is providing all of the probabilities that are represented, as well as how we might think about a solution. And so he talks about a portable oasis, and then you could see the graph, but not so much the details of what that might do in terms of affecting the water sanitation problem. And then in the middle here, you have a scratch game that a student developed for our transformations unit PBL, where I challenged students to think about how transformations on a coordinate plane is similar to the applications of creating a video game when we're moving figures left, right, up, down, rotating them and flipping them. What does that look like? And so I challenged my students to create a scratch game. And so they coded a game, and I gave them the choice to choose the context that they wanted. And so for this particular one, the student Ria here is creating this little rabbit, so we can see the rabbit moving left, or excuse me, right, but it can also move left, navigating through these different scenes. And as the rabbit goes and is answering these riddles as Ria's game is designed, we could have chests that open. In later scenes, there are objects that flip and turn. And so again, the projects should not solely serve as a product, but should be a demonstration of how much the student has acquired in their content understanding in order to produce something that shows that off. So these are the project design elements. And now I want us to think about the question, what do teachers need to do to support students in a PBL learning environment? And PBL Works, again, shares 7 teaching standards for project-based learning. And the first one is pretty straightforward. We want to think about the design and the plan of that project. We could either create our own or adapt a project that already exists to meet the context with which we're teaching in and the students that we have. Again, all of this needs to be rooted in our knowledge of our students at the time that we have them. And so we don't want to do anything that's too far out of their reach, but still something that is challenging from beginning to end. And really, throughout this design and planning process, we have to think about the standards that we want to address. What are the content standards within our courses of study that we're looking for students to gain understanding as they engage through the project, right? So they're learning the math content, they're learning math procedures as they work through their project. And all of this needs to be coming from the design and plan aspect of things, as well as us thinking through what aspects are we gonna allow students to make decisions for themselves, and where are we making decisions for them. All of this does not come naturally to us or our students. And so building the culture for this is going to be incredibly important. And that's where the latter half of this presentation is going to go, is thinking about what that might look like in the math classroom, how we would build the culture for us as teachers, for students in order to really engage in this work, for them to learn how to be independent, to develop a growth mindset, sustain that inquiry of asking good questions and how we as teachers would respond to those questions, building up their ability to collaborate and work together, and then paying attention to the quality of their work, again, from a math side of things before we transition to a full-fledged project. The other standards for PBL are to manage student activities. This is where, as we're going through the designing and planning process of a PBL, we're thinking about, okay, these are the set times with which I want students to submit work to me as checkpoints. Here's the final deadline for the final project. These are moments in time where I'm going to engage with my students in order to provide feedback. And as we're thinking about the feedback and we're receiving student work at these checkpoints, at these scheduled moments in time, we as teachers are still having to scaffold student learning. It might be that at certain checkpoints, we see students are not demonstrating the level of proficiency and understanding in a topic within this larger unit. And so we have to provide some additional lessons and differentiate our instruction in order to meet those needs. Students might need additional tools that we haven't showed them in order to be successful in engaging their project. So we want to make sure that we're scaffolding that learning and we're differentiating our instruction in order to meet the student learning needs, as well as reaching the students' project goals at the very end. Again, as we're thinking about how we support students, all of that has to be rooted in some kind of assessment practice. So ideally, it's formative, as the public product itself is something that is summative. And so as students are engaging with their project and are developing that final product, we're alongside those checkpoints using formative assessment pieces, and those could be conversations, observations, rubrics, that we are assessing where our students are at in their understanding and helping them move forward in their understanding. A key part to the assessment is that not only are we assessing our students, as the teacher, but students are assessing themselves and engaging in this self-assessment, and their peers are also assessing each other in order to make sure that we all are on the same page with where we're at and knowing where we need to go. And lastly, the last teaching standard here is for the teacher to be that coach, that supporter, that encourager, the one who celebrates the successes, but also recognizes when students need additional skill building or redirection, that we're also there, sort of like a GPS system where if the kids are starting to get off track a little, we're helping to reroute them back to where they need to go. And, all of this, again, is probably unfamiliar territory for those of us who have not engaged in deep PBL learning. Most of us stay within our math teaching practices and really think about the content side of things and how that might look. And so I really want to think about the building the culture aspect of the teaching standard and how we might, as math teachers, build that culture for us and for our students. And the work that I'm going to share is from Peter Liljedahl's work, Building Thinking Classrooms. And so the question that I'm posing is, how does a thinking classroom support PBL for teachers and students? Now, Peter's research highlights 14 teaching practices that he organizes into 4 toolkits. So that's what you're going to see on the next few slides. What I want to do, though, is spend time really digging into a few of the 14 practices in each toolkit that I think lend itself really well to developing the culture that we need in order to sustain a strong project-based learning environment. So the first toolkit has these 3 practices, the first of which is using high-level math tasks that Peter calls just thinking tasks. Right? In order for our students to engage in thinking, we have to provide them the opportunities to think. And those are low floor, high ceiling tasks that have multiple entry points for students at all levels to engage and access the task, but is versatile enough to where we as teachers can ask questions that further challenge our students and provide extensions for those who need it, while also helping our students who might not be at those higher achieving levels yet, still learn the content as needed. Vertical random groups in this particular toolkit is huge. If we think back to the skills that employers are looking for, that ability to collaborate and that teamwork, and you're doing that type of work again in a PBL environment, you want to model that and what that looks like prior to engagement in a project itself. So using any kind of randomness, it could be cards, it could be an online random group generator, but we're creating random groups visibly so that students see we're not having any kind of preference or bias for how we're putting students together, so that they can work with each other, so that they can leverage the assets that are present in their groups in order to make sense of and understand the content that we're presenting to students on that day through those math thinking tasks. And then lastly, the use of vertical non-permanent surfaces. And I want to focus on the non-permanent aspect of this. When we're providing student supports to engage in their thinking on a non-permanent surface, I think it increases students' abilities to take risk, right? They might make a mistake, but that mistake doesn't have to stay there. They're able to erase it and rewrite their thinking, rewrite their learning. And that's a skill in terms of the perseverance side of things that allows for sustained success in a PBL environment. So if we want our students to be able to overcome obstacles that they might come across in a project, we have to give them the opportunities to overcome obstacles in their learning to begin with. And that might be an obstacle in a math task, but if we provide them a vertical non-permanent surface, then they're going to be more likely to take those risks and without fear, push themselves to think harder, think more, and think longer. The second toolkit has 5 practices, and I want to focus on 2. I'll share all 5, but I want to focus on 2. So Peter has this idea of defronting the classroom, which I think is a great segue for kids to think about how knowledge is not centered in one location, especially as they engage in a project. That knowledge can come from anywhere and any work. One of the first practices that I want to focus on is the keep thinking questions aspect. And when we're supporting students in their learning, they tend to ask questions that fall into 3 categories according to Liljedahl's research. And it's proximity questions, where students ask us questions if we're right next to their group, questions that stop their thinking, and then questions that allow them to keep thinking. And it's these keep thinking questions that we as teachers need to answer, and answer in ways that continue to sustain that thinking. If we think back to the project-based teaching standards and the project design elements, there's a piece there that is sustaining inquiry. So if we allow students to ask questions about mathematics, and we are only answering questions that keep them thinking about the mathematics, then when they engage in the project itself and they have questions, then we're going to be able to continue to support them in answering those questions to further their thinking about the project. So that's really a practice that we want to focus on. Providing verbal instructions is the third practice in this toolkit. This really is serving as removing a literacy barrier if our students are not reading at appropriate levels. And so we don't want to provide just huge blocks of text that would prevent students from accessing the task or the instruction in the lesson. And so we want to provide that verbally, maybe alongside some visual cues to help them understand what's going on. Check understanding questions is the idea of reframing homework. And this is the other practice that I want to spend a little bit of time on. And so as opposed to homework where students are used to doing the homework, getting a grade for it because that's what the teacher requires and that's what they're making me do, we're calling it check your understanding questions so that students have the opportunity to choose, do they work through these problems if they need to, or do they not? And prior to giving students choice in a project, we have to give students choices about their learning, whether it's in the classroom or at home. And we can start with these check your understanding questions. We provide students the opportunity to choose whether or not they want to engage and solve these handful of problems that we've picked or not. And it really puts the onus on the student to think about where they're at in their learning. And then the last practice here is to mobilize knowledge. And that's, again, when students are writing on these vertical non-permanent surfaces, they're able to look around the room to see what other groups are doing, what other students are thinking about, and then encouraging students to not only ask us as the teacher for answers, but for them to ask each other. We can redirect students from a group who have a question to another group where we've answered that question previously. And so now knowledge is not coming from the sage on the stage, us as the teacher, but knowledge is coming from others. And it's an active, collaborative creation of that knowledge and understanding in the classroom. The third set of toolkit practices begins with hints and extensions. And so if we're thinking back to the scaffolding student learning practice, or teaching standard, it falls well into this hints and extensions. As students are engaging in the high-level math tasks that we provided them, we want to make sure that there is consistent flow in their thinking. So for our students who are struggling, might have a question, or coming up against something that could prevent them from further moving along in the task, we want to provide them hints that does not lessen the cognitive demand, but does serve to remove a barrier that allows them to keep moving forward. For our students who are higher achieving and are moving at a faster pace, we have to also be prepared with extension questions and challenges that allow them to push on the depth of their understanding to further their knowledge of that particular concept or procedure. At the end of these lessons, we want to consolidate the learning that's been taking place. We, as the classroom teacher, are still the experts in the room. And so we want to help students make the connections across different solution strategies and solutions themselves so that kids have the opportunity to see other ways of knowing and doing and thinking that can still be the appropriate way to getting to a solution. Might not be efficient, but still an appropriate way of getting there. And then, again, providing students choice, having them write meaningful notes to themselves. It's not lecture style where the teacher is giving the notes, but after the consolidation phase, giving students the opportunity to see what has taken place in class that day, and they get to choose what they record for themselves so that they can go back and refer to it. And this could be more structured in the sense of providing the students a graphic organizer so that they have an idea and a set of suggestions that they might consider when they're writing these meaningful notes to themselves. And then the last toolkit has the final 3 teaching practices, which is evaluate what you value. And a lot of this evaluation of what we value is very skill-oriented and process-oriented. If we value perseverance, risk-taking, the ability to collaborate, communicate, those are things that we want to assess our students and communicate with them. This is where you're at, and this is where I need you to be. You're not communicating well. This is what I've noticed. And if we have some kind of rubric that illustrates, what the expectations are for where we want them to go, and then it allows our students to really be more reflective in what it is that they're doing in order to meet us at the expectations that we've set forth. A navigation tool to help students understand their learning is, I think, ideal to begin with content. It really supports the PBL side of things. So if we're thinking about a quadratics unit, and part of it is different ways of solving quadratic equations. It could be factoring, using the quadratic formula, completing the square, etc. If those are our strategies and those are concepts and procedures we're looking to assess from our students, we're providing some navigation instrument, some kind of table format of these are the skills and these are the question types associated with those skills. And we could think of those question types as DOK levels, depth of knowledge, or as Peter has it, basic, intermediate, and advanced, and really showing students, these are the types of questions that fall within this category for this particular skill, concept, procedure, and working with them from where they are and where we need them to be. When it comes to the project-based learning side of things, providing students with a rubric of what an exemplar looks like and where their product currently is at is very similar to this idea of a navigation instrument with content to help move our students forward when they engage in both their learning as well as the final product for a project. And then we want to make sure that we're reporting our grades based on data. It should not be a compliance monitoring sort of thing where we're giving students grades if they completed the assignment or if they completed a certain checkpoint. We want to make sure that we're collecting data that's meaningful about their learning, and that is what we're reporting on. And so that data collection instrument can build off of the navigation instrument, and just making sure that we're communicating to our students and to their parents and families that the grade is a reflection of the learning that has taken place, not necessarily solely about how much they got done or completed. And so knowing that we have to build the culture for our students and thinking about how these practices support that culture building before we engage in PBL, here are my recommendations for getting started. And it builds very much, on the first teaching practice that Peter illustrated. And that first toolkit really is to use high-level math tasks in collaborative groups. So if our students don't have the opportunities to think and are not working with each other prior to engaging in a project that's collaborative, they will struggle. They won't have the capacity to have meaningful conversations and to persevere in their thinking in a project if we haven't given them the opportunities to do that ahead of time. And so a couple of tasks that I have here that are some favorites of mine that are easy for students to get started and for us as teachers to get going fall into 2 categories, non-curricular and curricular. So if we think about some of these non-curricular tasks, the Decompose 25 task is one that Peter highlights in his book. And it's simply thinking about how we can decompose 25 into its add-ins, and then what is the product of those add-ins? And from there, what decomposition of 25 will yield the greatest product? And so it's pretty easy for kids to think about, I can break 25 into 10 and 15, or 5 plus 5 plus 5 plus 5, and then multiply all of that together and think about the product. And so it's accessible. Kids have the knowledge in order to do that. So this is an opportunity, again, thinking about low floor, high ceiling tasks. The 4 4s is another one where I challenge students to take the number 4, and you have 4 of them, use any combination of operations and grouping strategies in order to create the numbers 1 through 20. Again, something where students have access to these operations, are familiar with these numbers, and then can push themselves to create these solutions from 1 through 20. The painted cube task is a classic that I have borrowed from Joe Bowler's U Cubed site. And it's thinking about if we were to drop a 3 by 3 by 3 cube into a bucket of paint, how many of those individual unit cubes, the 1 by 1 by 1s, have 3 faces painted, 2 faces painted, 1 face painted, and then 0 faces painted. And then from there, we can extend that to what about a 4 by 4 by 4 case, a 5 by 5 by 5 case, and then a general n by n by n case, and really abstract some of that thinking. 3-act math tasks are great ways that are using video to engage students and getting them to think mathematically. And if you're wanting to look for more curricular types of tasks, something like the pool border task, where we're looking at a square pool and the number of tiles that go around that pool, could be a way for us to have multiple representations of algebraic expressions and what that might look like. Or if we're looking for something a little bit more in-depth, the dream job salary task is one that I can use for students to consider comparing linear, exponential, and quadratic functions, and which of these jobs has the better paying salary as we explore these different function types. So we have to give our students opportunities to think. That requires us to use and provide students high-level thinking tasks, and then encouraging them to work in these collaborative groups. Next, we want to continue to provide students ongoing formative feedback. That could be through conversations and through observations that we're noticing, questions that we ask as they engage in the task, but we also want to provide students with some sort of navigation instrument as we're going through a unit of instruction, so that they can see where they're at relative to where they are going. We want to provide them opportunities to self-assess along the way in a math instructional unit before they have to self-assess as they engage in a PBL, so that they know what it is that they're looking for and how they might move forward. Additionally, we want to provide students varied opportunities for them to share their thinking and their learning prior to assigning a project. If we're going to give our students the choices to, produce whatever they want as a final public product to demonstrate their learning in a project, we have to give them some choices to demonstrate their learning prior to that, so they build up the capacity for sharing, and we as teachers build the capacity for assessing the varied ways in which students are demonstrating that learning. So in addition to traditional assessment measures like tests and quizzes, we might provide our students opportunities to interview classmates, or we interview our students so that they're talking to us and we're listening to how well they're thinking about a problem and what they've learned. Similar to that, we might provide our students opportunities to record themselves explaining a topic or a concept or procedure. Our kids are very familiar with social media, so if they're used to making TikTok videos, we could challenge them, to make a TikTok about what they know, what they've learned. Or we might provide our students the opportunities to create some kind of diagram, flowchart, graphic organizer that's demonstrating how much they've learned about a topic, concept, or procedure. Again, providing our students with choice to allow them to share their voice in their thinking and their learning. And I want to close with, as you're thinking about developing your first PBL, be cognizant of a strong PBL project is designed to support students learning concepts and developing procedural fluency along the way. We don't want to lose sight of the mathematics. And so I would encourage you to think about, as you're getting started, to identify a topic or a unit of study that lends itself well to a project. For me, I always want to ease my kids into things, and so, and myself, a data analysis unit or a geometry unit might be the easiest way to do that because of the real world context that we can think about. And that leads into the authenticity element of the project itself. What problem or question can you pose that's going to make the thinking and the work that students engage in authentic and relevant. What context, what personal student issues might you use to help you frame the question or the problem that you're having students investigate? We want to make sure that all of that is aligned to our content area standards from our courses of study. So what standards do you intend for students to learn and engage in as they're working through their project? Again, as teachers, we have to make the decision as to what choices we're going to give our students. So what are you going to decide for your kids, and what are you going to allow students to choose for themselves? That's a question that you have to answer during that designing and planning piece of the PBL, so that students are not caught off guard, and you know and you have a strong idea of what choices they have and what choices you're making for them. You want to think about checkpoints throughout the project for when students are submitting things to you, so that you can provide feedback. And when you do provide that feedback, what kind of feedback are you going to give to students? And how are you going to give that feedback to them? Are you going to give feedback verbally, or are you going to give it written? How do you ensure that students take the feedback and apply it towards making sure that their final product is high quality? Right, so we want to be thinking about those things. And lastly, I encourage you to develop a rubric. Before you assign anything, if you can develop a scoring rubric that includes all of what you want to assess, and think about what an exemplar project might include, then it allows you to make a lot of these decisions a bit easier when it comes to the checkpoints, the voice and choice, the standards, etc. So that concludes my presentation. I want to thank you all for listening, and now I'm going to open it up for some Q&A, and hopefully I can answer your questions. Thank you again.
What has been my biggest challenge in starting all of this? It's a great question. I would say, building up that culture for students to really engage in the work meaningfully. I think one of the hesitations for us to get started is, when we assign students these projects and they're working in groups, we're giving up control of the classroom in the sense of students are working asynchronously and with what it is that they're exploring and what it is that they're doing. And so for me, just making sure that I'm cognizant of where all students are at progress-wise in their learning of the content, in their development of their final product. And so just being mindful of the time for, how am I checking in with my students? Have I ever recorded myself? I've recorded myself teaching for national board certification and the presidential award process. So I have filmed myself in those settings, but not often or frequently. And I'm trying to be wary of time too. I realize it's 1:40, and so I think some of the other sessions are getting started. Trina, I see your question. What might be ways for teachers to find collaborative networks to engage more in learning about PBLs? I would say if you're just getting started, PBL Works has a great website and a great blog. And so if you're interested in, figuring out already designed projects to use in your classrooms, PBL Works has a lot of great resources there. That's one that I go to frequently, and I'm not too sure about others for resources, but I have come across a variety of Facebook pages that are groups where people share a lot of ideas as well. And I think if you search those, you might be able to find a strong network to collaborate with. But again, I am cognizant of the time that I have. So thank you all for attending and watching, and hopefully you can watch the recording as well if there are any additional questions. All right, thank you. Thank you, Ken.